Alright, we're continuing on with section 12. I'm sorry, no, this is 13.1. Boy, does time fly. We're finally on chapter 13, relative extrema, and we're doing number 6, problem 6. So we're to find the open intervals on which f is a increasing, b decreasing, and c find the x values of all relative extrema. We're given a derivative. The derivative is f prime of x equals 2x times x minus 1 cubed. Alright, so this equals 0 when, so the critical values are the points at which the derivative equals 0. The critical values are going to be 0 and 1. So let's set up some intervals here. There's going to be a negative infinity to 0. That's the first interval, and then we're going to have 0 as the critical value. Then we're going to have the interval 0 to 1, and then we're going to have the critical value 1, and we are going to then have the interval from 1 to infinity. We have to evaluate the derivative at values less than 0 for 2x and for x minus 1 cubed. Alright, and then that's going to tell us what f prime of x is. And then we're going to be able to say whether the function is increasing or decreasing on the interval, and then that should allow us to then identify the relative maxima and relative minima, also known as the relative extrema, which is maybe another way to characterize some of your relatives. I know it's definitely a way to characterize some of my relatives. They're a bit extrema. Alright, anyway. Okay, so let's first plug in -1 for this interval here. So if we plug in -1 for 2x, we're going to get a negative. And we plug in -1 here for x minus 1 cubed, we're going to get a negative number cubed, which is going to be negative as well. So a negative times a negative will give us a positive derivative, which means that the function is increasing on that interval. Alright, then let's look at the interval between 0 and 1. Let's plug in 0.5. 0.5 times 2 is going to give us a positive value. 0.5 minus 1 is going to give us a negative value. So positive times a negative will give us a negative value for the derivative, which means that the function is decreasing. And that means that 0 is going to be a relative maxima, because to the left of it, the function is increasing, and once you get to 0, it starts to decrease. So 0 is going to be a relative maxima. And then finally we have the interval between 1 and infinity. Let's plug in 2. 2 times 2 is 4, which is positive for the first portion of the derivative, and then we're going to plug in 2 for the second portion of the derivative, which is going to give us 1 cubed, which is positive as well. Positive times a positive is positive, so the function will be increasing for infinity after the critical value, after it hits the critical value of 1. And so because it's decreasing first and then it's increasing after it gets to 1, that means we're going to have a relative minima between at the point 1, at the critical value 1. And that's it for this problem.